Hello, I'm Dr. Russell T. Warren. I have made this video to describe an article that my co-authors and I have published in the Journal of Educational Research on the Advanced Placement, or AP, program. AP courses are high school classes with the curriculum that corresponds to introductory college courses. Towards the end of the school year, students take their course's AP test and earn a score ranging from 1 to 5. The university that the student later attends then decides whether to grant the student course credit for their performance on the AP test, with most universities choosing to award credit when a student earns a score of 3 or 4. The AP program is administered by the College Board, which is the group also in charge of the SAT. The AP program is hugely popular. Every year, over 2 million high school students take more than 4 million tests. The federal government estimates that about 1/3 of students in the United States will take an AP course during their high school years. Despite the popularity of the AP program, there is actually not a lot of independent research on its effectiveness. The College Board has produced studies for many years on the program, but it's only been since roughly 2000 that outside researchers have been conducting large-scale studies on the AP program. One major challenge with research in the AP program is that traditional experiments with random assignment and control groups are nearly impossible. School personnel choose whether to offer AP courses, and students choose to enroll in them. Therefore, making comparisons between AP students and non-AP students is not very helpful because any differences between groups may be due to differences in motivation, school characteristics, or interests in the classes. As a result, it is very important that researchers control for differences in the two groups of students. In this study, my co-authors and I were interested in whether AP students had higher academic achievement than non-AP students after controlling for intervening variables. We obtained data from the Utah State Office of Education on every public high school student in Utah in the graduating classes of 2010 and 2011. We divided the students into 4 groups: non-AP students, AP exam non-participants, AP exam non-passers, and AP exam passers. Non-AP students were students who did not roll in the AP course and did not take the AP test. AP exam non-participants are students who were enrolled in the AP course but did not take that course's AP test. AP exam non-passers enrolled in the AP course and took the test, but they earned a score of 1 or 2 on the AP test. Finally, AP exam passers were students in an AP course who took the AP test and passed it. Our outcome variable was the students' ACT scores. The ACT is a college admissions test. Like the SAT, the ACT measures what students have learned throughout their high school years. Students receive a score on the 4 sections of the ACT: math, English, reading, and science. These 4 scores combine to form an overall composite score. All ACT scores range from 1 to 36. In 2014, the average ACT composite score was 21. There are over 30 AP tests, and it would not be practical in a single article to analyze the impact of all those courses, so we selected 2 of the most popular AP classes: English and Calculus. We analyzed the classes separately, so a student might be an AP exam passer in English and a non-AP student in Calculus. Because in Utah, students must almost always have completed pre-calculus before taking AP Calculus, in our analysis of calculus classes, we only analyzed data from students who had completed pre-calculus in 11th grade or earlier, because those are the students who were eligible to take calculus while still in high school. Because we could not force students into AP classes or to pass the AP test, we needed to control for differences in these groups of students. We did this through a procedure called propensity score analysis. The procedure is too complex to describe here, but we used it to control for about 70 variables in the 2010 cohort. Some of these variables included state-mandated test scores in math, science, and language arts, course grades, overall GPA, socioeconomic status, race, gender, and special education status. Most of these variables were collected multiple times in the student's high school career, and we controlled for those variables every time they were collected. After we removed the influence of those variables as much as we could, we compared the ACT scores from the 4 groups. In this video, I'm only going to show the results for the total ACT composite score from the 2010 cohort. but you can find the results for the 4 ACT subsection scores and the 2011 cohort in the article. The full results are broadly similar to what I present here in the video. First, the AP English analysis. Compared to non-AP students, AP exam non-participants had ACT composite scores that were 0.227 points lower, a difference so small that it doesn't really matter. When comparing AP non-exam students to AP exam non-passers, there was a 0.508 point difference favoring the students who took the AP test. This is a larger difference and enough to help some students obtain a slightly higher ACT score. But the score difference between exam non-passers and AP exam passers was 2.82 points, a huge difference that for some students means that they can attend their first choice university instead of another school. Now for the AP Calculus analysis. The difference between non-AP students and students in AP Calculus who did not take the AP test was 0.325 points. Just like the AP English results, this is a trivially small difference, but at least it does show a slight positive impact for taking the AP course. Students who took the AP test but did not pass had a 0.267 point advantage on the ACT over the classmates who did not take the AP test. But the AP test passers had a 0.978 point advantage over their classmates who did not pass one of the AP Calculus tests. The numbers I'm saying are slightly different from the numbers you see on the screen, because the numbers on the screen are comparing the AP students' improvement on the ACT compared to non-AP students, whereas I'm comparing groups one at a time, non-AP with AP non-participants, AP non-participants with AP exam non-passers, and AP exam non-passers with AP passers. So numbers on the screen are the improvement we would expect in students if they moved from being non-AP students to passing the AP test. So what does this all mean? First, the AP program is beneficial for students enrolled in it. Differences that researchers see between AP and non-AP students cannot merely be explained away as being a product of economics, race, or prior academic preparation in core academic subjects. The AP program seems to bestow academic benefits on students that are independent of the rest of their high school experience. Second, not every AP student receives academic benefits. The boost that the AP program gives to students is confined to students who take the AP test. There is no evidence that merely enrolling students in AP courses provides any meaningful academic benefits for them. The benefits of the AP program come from preparing for the test, with the greatest academic boost coming to students who pass the AP test. With the rapid expansion of the AP program and the desire that some well-intentioned school personnel have to give every student the AP experience, these results should be concerning. If students are unlikely to take AP tests, then there is no point in enrolling them in AP courses. Every scientific study has limitations, including this one. One problem is that we did not have data about student characteristics that may have had an important impact on ACT scores, such as motivation, time spent studying, and interest in academics. Some aspects of these variables are captured in the 70 variables we did control for, but there are likely unique influences of these variables that are not included in our statistical model. As a result, the estimates in the article should be seen as maximum estimates of the impact of the AP program, because the statistical model would attribute anything missing from those other variables to being a positive impact of the AP program. Another problem with this study is that many students in the sample took more than one AP test. If the impacts of AP are cumulative across multiple courses, or if they don't kick in until the third or fourth AP class, then those results would not show up in our study. Finally, we did not investigate school or teacher characteristics, which may be important in how the AP program functions. On the other hand, this is one of the strongest studies ever conducted on the AP program. No other researchers have controlled for as many variables as we have, and most studies on the AP program do not have as large of a sample size or a built-in replication. We also find it telling that two other studies, one from Harvard University and the other from Georgia Tech University, have similar findings. Thus, we believe that our results are robust and apply to the school population at large. This is just a short summary of the article. I encourage viewers to read the entire article by clicking the link below. This is an open access article, meaning it is available for free to anyone. My co-authors and I appreciate the financial support and efforts of Taylor and Francis and the College of Humanities and Social Sciences at Utah Valley University, which made the article an open access article. Thanks for watching.